So this video is going to be on lesson 3.3. And 3.3 was on the symmetry of freefall. Now that was a really important lesson, mainly because it helped you establish a lot of assumptions you can make. And the first assumption that you can make is, well, that your velocity in the y direction, and hopefully you watched the videos that preceded this video that I told you to watch, the the velocity in the vertical direction at your highest point in time is 0. So your Vy at your maximum height, at your maximum height, your velocity is 0. Now, you can quite clearly see it here because you don't see any vertical vectors anymore. Also, if you look at this GIF right here, you'll see that your velocity in the y direction is 0, right? There's no more velocity vectors anymore. There really isn't a velocity vector anymore. Now, let's move on to another assumption you can make. And the next assumption that you can make is, well, let's say the velocity that I launch with is 60 meters per second. And let me actually make it a bit clearer. Let's say velocity that you launch with is 60 meters per second in the vertical direction. Well, that must mean that your velocity coming back down, must be negative 60 meters per second. Right? So your velocity coming back down must be negative 60. So this is really just the symmetry of free fall. Now another assumption you can make that, well, if it takes you, let me use a different color for this. If it takes you, let's see, what color should we use? Sure, orange. If it takes you, well, let's say 1 second to go to your maximum height, right? So it takes you 1 second to go up to your maximum height, right? It takes you 1 second. Well, then the entire trip, right? The entire trip is going to take you 2 seconds. If it takes you 1 second to go up to your midway point, your maximum height, well, then your entire trip is going to take 2 seconds. And so that's another assumption you can make, right? Really, it depends on what the problem is saying. And let's talk about distance. Let's talk about your vertical distance up and your vertical distance back down. Right? So let's say you start at a height of 0 and then you end up at a height of, again, I'm making these numbers up. These are not real numbers. Your height is 2 meters. And then your height goes from 2 back down to 0. Well, in both cases, you travel 2 meters. Your vertical distance upward is the same as your vertical distance downward. And your total displacement, and so while your vertical distance might be, your total distance might be 4 meters, right? Because if you go up 2 meters and then you go down another 2 meters, the total distance you travel is 4 meters. Well, then your total displacement, your total vertical displacement is going to be 0. If you don't know what displacement means, I urge you to look in one of the previous lessons, because you should know what displacement is by now. If I have to keep So actually, I'll just explain what displacement is. Displacement is your final position. Is your final position, position minus initial position. Right? So really, again, these are all assumptions you can make. Right? So let's summarize them all. Where's my erase all button? So we can say that my velocity in the y direction, in the vertical direction, and my max height is 0. Right? That's always the case. And my time up is equal to the time it takes to come back down, which means my total time of this trip, total time object spends in the air. Total time object spends in the air is going to be 2 times the time it takes to go up. Right? So if it takes you 1 second to go up and 1 second to come back down, well, your total time is 2 seconds. Right? And so also your distance up, right? The distance up is equal to your distance down in the y direction, right? In the y direction. And also your total displacement is 0. This really just depends on understanding the difference between distance and displacement, which is a video you can watch in part 1 of the review guide. What else? Yes. And also, well, if your initial vertical velocity right here, initial vertical velocity, it must be negative, right? So if this is 60, then on its way back down, it must be negative 60. So Vyi is equal to negative Vyf there. It really depends on the context of the problem. All right, so let's actually do those problems now. Let's actually go through those problems. So this is the first problem on your homework. Basketball jumped straight up to grab a rebound. If she was in the air for 0.99 seconds, well, how high did she jump? Again, it's always important to really draw what you're reading, right? So this might not be exactly straight. So it says if she was in the air for 0.99 seconds, how high did she jump? So what they're actually saying is that if she was in the air, they mean her entire trip, right? It means from when she goes up and then when she comes back down. That's what that means. But the question is not asking that. The question only cares about how high this person jumped. So the only points they care about is the top point. The only point they care about is the top point right here. So let me actually erase this part. So we only care about 1/2 of this trip. And we know that, well, my velocity at the top is 0, right? Because we know your vertical velocity at the top is 0. Well, if we only care about 1/2 of our trip, that means we have to divide this time by 2. So that's going to give us a time of 0.495 seconds. And the question again, they want to know how high she jumped, which is dy. And now we also know something else. We know that acceleration due to gravity is negative 9.8 meters per second squared. Gravity is always acting on you. If you're in the air, if you're jumping, right? If you're in the air, gravity is working on you. Gravity, acceleration due to gravity is acting on you. So you have an acceleration due to gravity of negative 9.8 meters per second squared. Now, what equation do we use? Now, for the purpose of this, what you can do is instead of analyzing the path up, what you can do is, well, you can analyze the path back down, right? Because everything going up is the same thing as everything coming back down. It's just the opposite. So instead of calling this VYF, I'm going to call it VYI. And so now we can use a formula to solve for it. Because again, why can we do this? Because your path going up is the same as your path going down. Everything else is equal. They're symmetric. It's just opposite direction, which is why we can do this. So instead of analyzing my path up, I analyze my path downward. So now I'm going to solve for this question. I'm going to use a kinematic equation, right, which is d is equal to VIT plus 1 half AT squared. Because it has everything we need. We have VI, we have T, we have A, and we have D. And we're solving for D. So D is equal to 0 plus 1 half negative 9.8 T squared. And we get some number. Based on memory. Actually, no, I don't know based on memory what it is. We get negative 4.9 times 0.495 squared. And we get negative 1.2. So we get negative 1.2 here. Now, obviously, this is not your height. Height is a scalar. What we just calculated right here is our distance downward, which should be negative. Our final answer is correct. It should be negative. But again, because going back down is the same as going up, but opposite, it should be a positive 1.2, which is C. Question 2. Question 2. A ball is thrown straight up from the surface of Earth. Which statement best describes the ball's velocity and acceleration at the top of its flight? We talked about this. Your velocity at the top part of its flight is 0, right? At the maximum height, velocity is 0. So that's at max height, right? And well, that means your velocity is 0, so it's either A or B. But again, this is something you should really remember, that your acceleration due to gravity is always negative 9.8 meters per second squared. So it's B. Your acceleration is non-zero. Your acceleration due to gravity at all points in an object's path is always negative 9.8 meters per second squared. So number 3. Ball is hit straight up with an initial speed of 27 meters per second. So we're going to draw it. So straight up, right? And so initial speed is 27 meters per second. And your acceleration due to gravity is negative 9.8 meters per second squared. Your initial speed in the vertical direction is 27 meters per second. And what is the speed of the ball 2.4 seconds after it has been hit? This is a pretty clear-cut question. Let me get a dark color. They want to know what is the speed of the ball. They want to know what is the speed of the ball 2.4 seconds after it's hit. So you're trying to find out what your velocity is. And again, you're going to use kinematic equations here, right? Hopefully this is something you remember from kinematics. You're going to use this equation because it's the only one you can use. You have VF, you have VI, you have A, and you have T. So VF is equal to 27 minus 9.8, T 2.4, and you should get 3.5 meters per second. So it's A. Let me just make sure, right? 27, I think it's 28, minus, wow, I have bad memory. What is it? Oh, it's 27. 27 minus 9.8 times 2.4. Yeah, it's somewhere around 3.5. So it is 3.5. Perfect. Now let's number 4. Number 4 is a conceptual question. At its maximum height and time, the speed of a ball is what? We talked about this. The speed of a ball at the maximum height in your vertical direction is 0. So there's a problem with this question. The problem with this question. I'm actually gonna re-edit this. So let me just redo this question. Yeah. So this is the original regions question. Now, what is the maximum height reached by the ball? So ball is projected upward, right? So ball is projected upward. So let's draw it projected upward with an initial speed of 49 meters per second. So your velocity in the y direction initially is 49.0 meters per second. The ball reaches its maximum height in 5 seconds. So right here reaches its maximum height in 5 seconds. We also know that, well, my velocity at the top, right? Your velocity at the top is 0. Velocity at the top is 0. So they want to find out, well, what is the maximum height reached by the ball? So what is the y? You can solve this multiple ways, mainly because you also know that your acceleration is negative 9.8 meters per second squared in the y direction. So now we just need to solve using an equation. What we can do to solve for d is one equation, which is this one, right? dy. I'm not even going to put the variable. Is equal to d vit plus 1 half at squared. So d is equal to 49, 5. Just plug in all our numbers now. We know what a is. which is t squared, so which is 5. 49 times 5 is, I don't know, 49 times 5, 245. 245 minus 4.9. 5 squared is 25. So this is going to give you 122.5. And then you're left with this number right here. So your maximum height reached was 122.5. Alternatively, you could have just used this. You could have just used this equation. This equation would have also worked. VF squared would have been 0, right? Because you're using 0, and then 49 squared plus 2, not negative 9.8 d, and then you solve for d, and your d would still be 122.5. It would still work. It would still work. Number 6. What is the velocity of the ball just as it returns to the point from which it was thrown? Well, it would be 49. Actually, no, it wouldn't be. It would be negative 49, right? Because again, this is a symmetry of free fall. When you throw the ball upwards and then comes back down, well, your velocity at the end there is going to be negative 49. It will be the same but negative. Number 7. What is the total displacement of the ball from the time it was thrown until it returns to the point from which it was thrown? Again, if you're starting at a height of 0, and you fall back down to a height of 0, your displacement, 0 minus 0, is going to be 0. All right? So that's the end of this video.